Aloha and welcome to this brief screencast on model design. And there we go. And when I talk about model, I'm referring, of course, to the model component of the model view controller design pattern. Hopefully, you all realize that that's what we've been implementing. We've talked about views, we've talked about controllers, talked about models a little bit, and we're going to delve into that in more explicitly in this module than we have before. Beforehand, we just were kind of creating classes over there and not really worrying too much about what they meant. So the model is a representation of the domain knowledge that you're trying to collect and reason about in your particular application. And in Play, this is implemented as a set of Java classes, at least in the Java version of Play. And so we'll have classes, we'll make instances of those classes. Those instances, may have relationships to other class instances, so you'll have some field and you might fill it with a link to another object instance. And the whole goal of the model, the domain model, is that any question that you might want to ask about your domain should be answered by manipulating that domain model in some way. Okay? So this is all, really fairly easy to do until you start worrying about persisting this data so that if the application were to crash, you could start it up again and still have the information about the system. Okay, life would be wonderful if somehow we didn't have to worry about this, because it's really I won't say that the persistency is the big problem. Designing the right domain model is a hugely difficult problem, but when you combine the hugely difficult problem of defining the correct kind of domain model with the hugely difficult problem of how do I store the darn thing, it's really a mess. And so this has been an object of a lot of research throughout the years. And really there's kind of three approaches to dealing with the persistency problem for domain models. We have relational databases, we have object-oriented databases, and we have these things called NoSQL databases. Relational databases are the 800-pound gorilla. They've been around for a long time. They have a very well understood semantics. You can reason about them. They tend to be fairly highly reliable. They're fairly cheap. They are robust. And the only downsides of them is that there's this thing called the object relational impedance mismatch, which is the idea that it's kind of hard to create a domain model using objects and instances in your programming language and easily, kind of make that into the tables, which is the representation that you need to use for relational databases. So that's a hassle. The second problem with relational databases is for certain kinds of object manipulations and certain kinds of domains, they cannot be that performant. As a result of that, kind of two other alternatives to relational databases are object-oriented databases, where you really have a much closer mapping between your classes and instances that reside in memory using your programming language and the actual persistency mechanisms on disk. There's examples out there. For whatever reason, they haven't gained as much traction as I would have thought they would have. They definitely get rid of the impedance mismatch problem, because essentially you've just got classes and objects, and it just persists that network of objects that way. But one thing that has gotten popular lately are these things that are called NoSQL persistent stores, and what those are basically you have a set of keys and values, and you just persist these things, and they work quite well, and they're quite scalable for semi-structured data. And there's some people who just believe that kind of they solve all the problems of the world, and there's other people who say actually they don't. You will see them around, and they're an interesting thing to look at. And so all of these have strengths and weaknesses, and I think it just depends upon your particular circumstances as to which you're going to choose. In this class, we're going to start off dealing with relational databases and using those as our persistency mechanism, not because necessarily it's the best way, but it's the kind of sliced bread version that I think you should have some experience with. Okay, so if we're going to deal with a relational database, we have this problem in our play program. We've got this model package, and we've got these model classes in there that are represented in our domain knowledge. Somehow we have to put them into a relational database, and conversely, when we've got some data in the relational database, we have to get it out somehow. And there's two ways to do it. One is the manual approach, where we write some code that goes into the database, and we have a SQL select statement, or we have a SQL insert statement, or we have a SQL delete statement, and that's the way that we deal with the database. We just write those statements, and that was the way that it's been done for a long, long time. And eventually, people said, it'd be really much more convenient if we basically just had a set of classes which were defined to be persistent at some high level, with some high level kind of declarative specification that this should be a persistent Java class. And then, and these declarations would essentially explain how some kind of underlying machinery would take those Java classes and basically translate them into the SQL statements, and translate them into the create statements to create tables, and translate them into the various kinds of indexes and so forth. Handle all that underlying relational database junk, and often Java land, we just be merrily manipulating Java classes after having specified this mapping between our Java classes and the underlying relational database. And that's this second approach called ORMs, or ORMs, or object relational mapping. This seems like a better approach, but the big issue with ORMs is that sometimes it just doesn't work out good. You can't map it exactly the way you want in order to get whatever kind of performance or representational issues that you want. So the ORMs kind of basically they work pretty good when you've got a pretty simple situation. When you've got complicated situations, then people start to fight against the ORM, and it becomes more of a hindrance than a help. And then often they fall back on going to the manual approach, or maybe even they abandon relational databases entirely and go off to NoSQL land. Okay, so Hibernate is again the 800-pound gorilla of Java ORMs. We're going to use something kind of similar to Hibernate in this class, but it's a little different, called eBean. But the basic idea is that we have this Java layer of Java classes, and when you see the Java persistence layer, basically what we're saying is all the classes in the models package, okay, is the Java classes that are supposed to be persistent, and then we feed it through this Hibernate system, which is going to manage all the interactions with the database. On the right-hand side, you can see that the way we're going to kind of magically tell Hibernate what to do is by adding annotations to our classes in the models class, like @entity, and then there can be a bunch of other junk that you put in there, which kind of specify how Hibernate is supposed to do its job. Okay? So it's a whole lot better than learning raw SQL and trying to manage that, but it is a whole new kind of language that you have to learn. Okay, so that's essentially what we're going to do. We're going to somehow be mapping, our Java classes to the underlying tables and so forth. And in order to kind of understand what's going on, you have to have an understanding of what your goal here is. It's important to know a little bit about entities and relationships and be able to kind of model your domain in those terms. So let's step away from the implementation details for a little bit now and just talk about the abstractions. What's an entity, what's a relationship, and how do they work together? So when you talk about entities, one of the things that you should immediately recognize is that entity is a very vague term, and it's probably better in your brain when you hear entity in the context of entity relationship diagrams and entity relationship modeling to think of entity type, okay? Because person is a valid idea for being represented as an entity because it represents a class of instances, and that's what entities in the ER modeling domain is really supposed to refer to. They should be a template or blueprint for a class of instances. So John Smith, even though in English John Smith is an entity, but in the entity relationship modeling, John Smith is not an entity. It really needs to be an instance of some entity type, which might be called person or employee or doctor or whatever. Okay? And then associated with each entity are one or more attributes that provide details about each specific instance and how each specific instance differs from each other. Okay? So entities really correspond in a lot of ways to Java classes, right? Which is very convenient. Okay? In fact, what we're going to do is we're going to think of Java classes as actually being instances of entity types. Okay, relationships are ways that we can link entity types together. Okay, and when you think about kind of understanding, relationships in the ER, modeling sense, it's really, really helpful to always think in terms of entity instances when you're thinking about relationships and not the entity types themselves. So it's really weird. So these boxes refer to templates or types of things, but the little lines with the little crow's feet things on them, those actually refer to relationships between instances of the entity types, not between the actual entity types themselves. So this relationship is talking about a relationship between an instance of a doctor, like Dr. Smith, and instances of the patient entity type, like Joe Dane and John Doe and all other kinds of specific instances. So once you get that into your brain, that whenever you think about relationships, you're always talking about relationships between specific instances of our entity types, then it gets a lot easier to understand what they mean. Okay? So there's three basic relationship types. Okay? The first one's called a one-to-one relationship, and that is when at most one instance of an entity A is associated with an instance of an entity B. Here's a representation of that relationship. We're going to use this thing called crow's foot notation, which I'm just going to show you examples of it in the next few slides. It's pretty trivial to kind of understand. The idea here is that we say a patient is related to 0 or 1 instances of a medical record. Let me put it more. A patient instance is related to 0 or 1 instances of a medical record. All right? So kind of more colloquial speaking, a patient has an optional medical record associated with it. Okay, now on the other hand, when you read it the other way, you say a medical record is associated with exactly one instance of a patient. Okay? And when you're looking at crow's foot, what happens is you see these inner icons here, the 1 and the 0, and then the outer icons, which is a 1 and a 1. Okay? So the inner ones you can think of as being the minimum cardinality of the relationship, and the outer ones being the maximum cardinality. So this says patient is associated with minimum of 0, maximum of 1 medical records. Medical records are associated with a minimum of 1, a maximum of 1 patient instances. So every medical record, a medical record cannot exist. An instance of a medical record cannot exist unless it's bound to a patient. Okay, that's what this 1-1 thing on this side says. Where when we look at patient instances, we can say, hey, a patient instance can exist without any corresponding medical record because we have this 0 for this one. Okay, so that's crow's foot notation and the one-to-one relationship. Let's move on to one-to-many. This says basically, on one side there's 1, on the other side there's possibly more than 1. Okay, so here's an example of that. What we're going to say is an instance of a department can have 0 to many employee instances associated with it, right? So we could have a department without any employees. Not sure how much work would get done in that department, but anyway, we could have a department with 0, 1, or many employees. On the other hand, When we read it the other direction, we say an employee is associated with a minimum of 1 and a maximum of 1 departments. So therefore, every single employee, when they're hired, every single instance of an employee gets assigned to a department. We can't have an employee not associated with any department because that would be bad. That employee would never have to come to work. He'd have no boss. He'd have no job to do because he doesn't have a department. Okay? On the other hand, we apparently can have departments in our mythical company that have no employees, so that department's probably not going to get much done. Last one is many-to-many relationships. Okay? And so here we have an example where there are projects. So a project instance, project foo, has a minimum of 1 and a maximum of many employees associated with it. So a project instance, project B, always has at least 1, if not more, employee instances that are working on that project. And then when we read it the other way, we see that an employee is always associated with a minimum of 1 and potentially many different projects. Okay? So pretty simple. Once you kind of get the hang of reading these little crow's foot things, and you notice that there's this minimum in the inner side and the maximum on the outer side of these little connections, you know, it's super easy to get. Okay? So that's enough to kind of get you started thinking about entity relationship modeling. There are going to be a bunch of WODs where we'll give you a narrative description and you're going to try to create diagrams. Hopefully that will give you a better sense for how this all works. It is harder than it looks. In general, you want to think about entity relationship modeling in terms of, you know, what queries you want to answer about your domain. It's going to help you a lot in terms of figuring out how you want to do this. So have fun.